A great detective completely solves the birthday paradox. By the way, it also solves the paradox of the 66-type random gacha. The question asks what the probability is that two people in a class have the same birthday. Assume there are 365 days in a year. If there are 23 people in a class, then the probability that two people have the same birthday is 51%. If there are 30 people in a class, then the probability that two people have the same birthday is 71%. The birthday paradox is when you feel that the probability is higher than you thought. We will explain the psychology behind why you feel this way. We will think of this as two separate processes, interpretation and calculation. This is because a problem expressed in words leaves room for interpretation. If the problem were expressed as a mathematical formula, fewer people would make mistakes since all they would have to do was calculate. In the birthday problem, we can predict that an error is occurring in interpretation. There are distinctive features in the process that humans use to interpret problems. For example, what is the total price of 16 items that cost 25 yen each? I think most people would interpret this as 4 by 4 by 25 4 by 100,400 and calculate it. I don't think there are many people who would try to calculate 16 by 25 in their heads in the same way as doing it by hand. This is because there are so many numbers that have to be temporarily remembered, which makes it difficult. Before calculating, humans try to interpret the problem in a way that makes it as easy as possible to calculate. In the birthday question, only two numbers are visible: 365 days and 30 people. Using these two numbers, try to interpret it in a way that is as easy as possible to calculate. You realize that the more days there are in a year, the less likely it is that the birthdays will match, and if it's one day, the probability is 100%. You also realize that the more people there are, the easier it is for the birthdays to match, and if there are 0 people, the probability is 0%. If you try to express this relationship using simple arithmetic operations, you get 30,365, approximately 8%. Some people may realize that 8% is not accurate because combination calculations are required. However, if you cannot do the calculation in your head right away, the only number in your head is 8%. If you are told the correct answer, 81%, you will feel that it is bigger than you expected. A similar paradox occurs with gacha probabilities. How many times do you need to draw to complete a gacha that randomly gives you 10 types? You need to draw at least 10 times. All you can see is the number 10 types, and you realize that the larger it is, the more times you'll need to draw. A simple interpretation is that you can only predict 10 draws. The expected value is 29 draws. It feels like more draws are needed than you thought. However, there are some people who feel that this is roughly as expected. These people are in one of two places. 1. They have done the calculations before. 2. They have actually experienced that they can complete the set by drawing about 3 times the number of types. The second person has the number 3 in their head. They estimate that 10 types x 330 times is the number of times they need to draw. This is a dangerous way of thinking. There are 66 different random gacha in the world. Empirically, we can estimate that you'll need to draw 66 by 3,198 times. The actual expected value is 315 draws, which is about 5 times the 66 types. You might misestimate the number of draws you'll need and end up in a bad situation. But it's also a great sales technique. This is the tool of evil civilization. That's all.